equally as important in being able to get the answer for the variable is to show the work exactly the way that I'm going to show you here. So double check, and if you need to rewrite it, I want you to write it exactly the way that I'm showing it to you. In all of the problems, your very first step is to rewrite the original equation. So I'm going to do that. What's being done to the variable a? I'm going to go with you because I'm going to talk you through this.
It's being changed to whatever number 8 times 8 will equal 4.
Okay, so in more or less, he's saying what I told you yesterday. We are taking the variable a and we're multiplying it by 8. We're going to do the inverse. We're going to do the opposite. What's the opposite of multiply by 8? And here's how we're going to show it now. This is now our division symbol. Divide by 8. What's the rule? Whatever we do on one side, you have to do the same thing on the opposite side. So we're going to divide this side by 8. Okay, and then you weren't here, but yesterday the reason why is think of an equation like a scale. If I have 5 on this side and 5 on this side and I'm equal, if I take away 2 from this side, I got to take 2 away from the other side to keep balanced. So I got to keep everything balanced out. On my left side, what cancels out? Brandon. All right, so I'm going to show that with a line going through it. And the only thing that's left now is the variable a, which is what we want. Our goal is to try to get a all by itself. And we have that. And now we just evaluate 24 divided by 8, which is 3. Now we're going to prove it doing a check. Same thing. Start by writing the original equation. Now I have a value that I think is a. I'm saying it's 3, so I'm going to substitute it in. Don't leave it like this. I know you know 8 times 3 is 24, but you want to actually evaluate this. This is right now in expanded form. Put this into standard form.
24.
Right. You want to get to this point right here when you have a number on the left exactly matching up with a number on the right. Now I know that this is definitely working, and I can circle it, and I'm done. Number 2. Ava, what am I doing to the variable g? Well, what am I doing right now? Before I do anything. Right now, what's being done to it? Help her out. We're subtracting by how much? Subtracting by 4. Now say what you were going to say. What's the opposite of subtract 4? All right. Take it step by step. For some of you, I realize it's really, really a slow process. Just got to trust my judgment. We've got to do it this way. Whatever I do on the right, I got to do on the left. So there's my adding 4. Eddie, what cancels out? Minus 4 and plus 4. Say goodbye. Tio, what's the only thing that's left on the right? No, that's the left. Spence, what's 32 plus 4? 36. Okay, let's see if it works. Rewrite the original. Dylan, what am I going to substitute in for G?
You are going to substitute. You're going to substitute 32. 36.
Yeah.
36.
What is it?
36.
36. Evaluate 36, take away 4. It's 32. And let me just give you a little bit of warning. Don't automatically just, once you get going, go through the motions. Sometimes as these get a little bit more advanced, students will make mistakes. Let's say for whatever reason, you put, I don't know, 30 here. The whole idea of the check is to make sure that everything works out. If you just kind of go through it and say, oh, 32 equals 32 or 30 equals 30, got to be careful, because the whole idea of showing this is to actually do the math to make sure that what you got for the missing variable is indeed the correct answer. So don't make basic math errors. And it's going to happen. I know. I'm going to see it on a quiz or a test. Probably after assessments we'll do something. And watch out for your careless math errors. 56. All right, let's see. Who haven't I heard from? Lukey, what are we doing to the variable j?
You're subtracting.
Well, what are we doing now? Don't even give me the opposite yet. What's being done right now?
Adding 29.
What's the opposite?
Subtracting.
What do I have to do on the other side of the tracks?
Subtract 29.
Train tracks.
Yeah. Yeah.
A lot of you brothers and sisters learned it as railroad track method. I was going to get to that too, but I think it's even more writing than you need as long as you understand the process. But let's just finish this up. Only thing that's left on the right.
27.
No, on the right.
Oh, on the right is J. 27.
Okay, let's sub it in. We're going to substitute in our 27. And again, don't automatically assume. What I would do, seriously, go on the side somewhere or even on scrap paper. Just double check and make sure. 7 plus 9 is 16. 2 plus 2 plus 1 is 56. And it does work. So we're good. I'm not crazy about number 4, because number 4, if you take this, and I'm going to rewrite it originally, you just have to subtract, and you're going to get the value here anyway. Okay? However, see? Always double check. Always double check. Thank you. The check, however, looks exactly like the previous examples or the previous exercises. Write the original. Substitute my value, which is 6, and get 6 equals 6. Okay. Let's move on. Number 5, it's just decimals, but it's the same process. You just have to remember your subtraction of decimals. The process is exactly the same. You're going to need some annex zeros, as you will see, but let's just do it. Opposite of take away 3.45. It's the opposite. The opposite of adding 3.45. Sorry. Did I say subtract?
Yeah.
Okay. Opposite of add is subtract. When I do this, what I would do is make sure my decimals line up, because you learned when you subtract or add decimals, you have to make sure the decimal lines up. You could do the math right here if you want. Add an annex 0 here, and then just be careful with your math. We know this is going to cancel, so here it comes. Can't do 0, take away 5, got to borrow. Did you get 9.35?
Yep.
On the check? Same principles apply. Line up your decimals. $9.35. Don't automatically assume. Actually do it just to be sure.
Not everyone can.
5 plus 5.
There's no carry on.
Right, don't carry on. 12.8 checked. this was putting together what you learned from lessons 18 and 19 and lesson 25. Alexa, what equation did you come up with? Mm-hmm. How many of you got that? That's kind of the hardest part, really. It's just formulating that. There is, I think, another way to do it. What'd you do?
I did 7 equals x minus 7.
Say it again.
7 equals x minus 7. Wait, what? And then it would be plus 7 on each side.
That'll work too. Yeah, it would. It would. Okay, let's do it this way. Add 7 to both sides. Cancel, cancel. And then to do the check, substitute your value in from your original. And it checks. And you're good. All right, one more, right? It's like, so how's it going so far? I mean, for those of you that were getting it, hopefully it's kind of just like, okay, you got it. And for some of you that were struggling with it, hopefully we've closed some gaps a little bit, because we're going to practice it again today, and we're going to practice it again tomorrow. The only difference is I'm going to show you in about 5 minutes 2-step algebraic equations. Okay? Problem set B is 2-step algebraic equations. So I'm going to give you a mini lesson on that here in a second.
I didn't get 7.
Okay.
I
Let's.
got every other one, but I didn't get 7.
16 ounces in 1 pound. A box of nails weighs 4 pounds. Using the variable W, I know I need that. Write and solve a division equation. I know I'm going to need that to find out how many ounces the box weighs.
4.
What's the equation?
W divided by 4. W equals 4 equals 16. It was a 1 because like W equals how many ounces are in 1 pound, and then 4 pounds. It equals 16 over 1. Yeah, that's what we got. I'm confused. It's like
Right now, though, as an equation, this is fine. What'd you get as an answer?
I got W equals 16.
Okay, so why do I have to put a one underneath the 16?
Dad thought because like
A ratio?
yeah.
Oh, yeah, okay.
Like the W is the ounces.
That's interesting.
Well, you always have to put
If you think about that you've really created a ratio there, is what you've done. And then you say, okay, well, look, here's my ratio, times 4 times 4.
yeah.
Which, when we used to do algebra, we used to do ratios in the same unit, and there's a relationship there.
It's a really simple way.
Leaving it the way it is, not a whole lot of room here to work, is there? It's tight. Okay. Real quick, divide by 4, the opposite is multiply by 4. Cancel, cancel. You get W by itself, and then 16 times 4 is 64, and you go through the whole check process.
I did W divided by 16 equals
Equals what?
I just did Wait.
That's not going to work.
Yeah, no.
Equals 4 would work.
Yeah. No, it was just throwing the addition instead.
So what?
Yeah, it was just 4.
Yeah, 4 would work. That would work too, yeah.
It was just carrying over from the
All right, let's do 2-steppers. Page 10. I really think you're going to be fine with this. I believe page 10. Yeah, page 10. As long as you know the rules for 2-steppers, it's going to follow exactly the same procedure as we did yesterday. So now you have 2 things being done to the variable. Here's your x. What are we first doing to it, and then what are we doing to it? What operation are we doing first? Aileen, by how much? Right. Oh, going back here, how is it different from the last? You have 2 operations. I've actually jumped ahead here. my advanced group can go in the hall and go. Did you guys do? Did you get to start the advanced two-steppers? Okay. After you're done with it with the two-steppers, guys, there's an advanced set for two-steppers. Somewhere after page 10, you'll just say, it'll say advanced set 1 through 5, two-step. All right, I'll help you. I'll show you. I'll come back to this in a minute.
Oh, I see it. It's on page 14 on the bottom.
14, yeah, it starts on 14, and then by the time you progress through it, you're actually going, your very last problem in that advanced set is a three-stepper. Okay? So if you want to go in the hall, or you can just stay here, doesn't matter, because I think you got it. Everybody else, though, let's go back to page 10 and do this. I really think if I show this to you, maybe once or twice, you'll get it. Hold on, Spence. Okay. So you have two operations going on. Alien says first we're multiplying by 6. Then, after that, we're adding 3. Okay? And then this little blurb at the bottom just explains that what we had been doing is one step. These are now two-steppers. Here are the rules. Important too. Highlight it, circle it, star it. Even though when you do order of operations, you do multiplication and division first, when you do the inverse, you're actually going to handle it backwards. You're going to undo the inverse of, you're going to do the inverse of addition, subtraction first. And then take care of any multiplication or division. And if that confuses you, I will show you in the example of what I mean. It's kind of the opposite of PEMDAS. Now when you check it, you'll still do PEMDAS the right way. So, based on these rules, the first operation that has to be handled first is your adding of 3, which is really the opposite, which you're going to subtract 3. That's what you're going to do first. And then the inverse of multiplying by 6 is what again? You'll do that next, or do that last. All right? And again, if it's confusing you, I'll do 2 examples, and I think you'll get it. So here it is again. Yeah. And I'm going to write it on my work column. Are you caught up, or do you need to get caught up? I think you're caught up. Some of you gone ahead. So by rule, I'm going to handle my addition subtraction first. So what's the opposite of add 3? So we're going to do that. What cancels out? I'm going to cancel that out. Now watch. There's still an entire term left on this side. I still don't have x all by itself. So what's left is not x, but 6x is still left. And I'm going to evaluate 27 take away 3 as 27 take away 3. And look, you're right back to what you did yesterday. Opposite of multiply by 6. Divide by 6. My 6's cancel. And now I evaluate 24 divided by 6, which is?
I now get that.
We're going to sub it in. Let's double check. 6x plus 3 equals 27. The value that I'm claiming is x is what value?
4.
I'm going to substitute it in. 6 times 4 plus 3 equals 27. Now don't get confused by this. We've done it. This is PEMDAS back from the beginning of the module. Who fights first?
6 times.
That's going to stay the same. Don't do it in reverse. Check it the normal way. 24 plus 3. And it checks. Let's do one. do one more together. Okay, we'll do one more together and I'll let you guys go. Okay, what do I do first? Scroll up. What do I do first?
You make the 8 into plus 8.
Got to do it on both sides. John, what cancels out? What's the only thing left here? Okay. 136 plus 8.
144.
Now what? Somebody else maybe. What do I do next? Oops. I know you know what the answer is.
Oh.
And that's okay. I realize that you could do it in your head, but there's going to be coming a point where you can't. So you've got to do the process. By steps, what do we do next?
By myself.
Divide both sides by 12. Got to show it that way. Cancel, cancel. And sure enough, 144 divided by 12 is 12. Okay, let's check it. Forgot the minus 8. Alright, what gets substituted in for x? Ben. Who fights first? Ava. Which is? 144 take away 8. Double check. Don't make any careless math errors. Make sure it is indeed 136. 136. So that proves that x is definitely 12. Kind of got it?
Yeah.
And again, you'll just practice it again tomorrow, but group up and go.